Now, today our topic is congestion control. Now, by congestion, what we mean that when there is too much packet present in the network, and then we have said that the network is congested, or the congestion is a situation when the uh, data carrying capacity of a network will be less and more packets will be on the network, or it means that the network is congested when the network is overflowed with the data packets, and the data carrying data capacity of the network will exceeds the number of packets present in the network. Then we have said that the network is being congested. And by congestion control, what we mean, how could we take rid of congestion when there is too much traffic on a network? And it is very similar to how the traffic is being controlled or on road. When the roads are flooded with uh, more traffic. Now, this congestion situation can be um, shown with the help of a graph. Now, what this graph is being showing here, this is the packet sent and this is the package delivered. And this line will be the maximum carrying capacity of the subnet or a network. Now, if the number of packets sent and the uh, number of packets delivered are same, then the situation, we said that the situation will be normal. That means there is no congestion in a network. And this is shown by this uh, uh, line, a straight line curve passing through the origin, and here the packet sent is proportional to packet delivered, and the packet sent and packet delivered is within the maximum data carrying capacity of the network. Now, if now the more packets are being sent through this network, then the delivery will be slower, and this one, that this graph which is shown here, the delivery will be delayed, because we have seen when there is too much traffic on the road, uh, it will be delayed, because the outgoing, how could we distribute the traffic, and due to that, there will be a delay occurred on the road. Now, if, and this condition is shown as desirable condition by this. Now, if there is too much traffic, then and none of the packets is being, the network cannot able to deliver a packet, then the network is congested, and uh, this curve is being shown when there is too much packet or too much traffic on the network. So the congestion will be shown by three situations: when the number of packets sent is proportional to the packets delivered, then the situation is perfect or normal. Now, if slowly congestion is being developed, the packets delivered will be delayed, and it is desirable. But when it exceeds and when there will be too much traffic on the network, then we said the network is being congested, and very less or none of the packets can be delivered through the network. Now, why there is a, yeah, oh, okay. Now, why there desirable means when the congestion is slowly built up in the network. That means the packets are sent through the network, but the packets delivered will be delayed. Little bit of delay occurs in a network. Same situation we have seen on the road. When there is too much car on the road, we will get late in reaching our destination. So here also, the when the congestion is slowly grew up in a network, the packets which has been sent through the network, the it will be delivered to some other nodes, but due to the congestion slowly being developed, the packet delivery will be delayed. That is their packets are being delivered, but delivered will be in delay. So this is a desirable condition. And but when the packets being sent through the network and none of the packets are being delivered, then we said that the network is being congested, totally congested. So perfect, desirable, and fully congested, or we call it to be a congested uh, network. That means we couldn't able to deliver the packet through the network. Now, in what situations this congestion will occur? Now you understood what we mean by perfect. When the number of packets sent is proportional to number of packets delivered, then the situation is perfect. When there will be a delay in a network, delay in delivery of a packet, then it is desirable. But and when none of the packets is being delivered, that congestion is that situation is known as congestion, or we said the network is being congested. Clear?
Yes, ma'am.
Now, why this congestion occur in a network? There are several factors in these situations. Suppose we are going to send the packets through router. This router is being shown, and in the router will accepts the packet, and it has a buffer to store the packets. And now here, the in this figure, what we have seen, the router is receiving packets through three input lines, and we have a single output line. That means all of the packets coming through the input lines 1, 2, and 3 through the router, and all of the packets is being sent through the same line. Then there will be a congestion in a network, and since the routers is receiving all the packets and its buffer is full, and due to buffer full, it will not able to send the packets through the same output line. So then in this situation, we said that the network is being congested. And if there is insufficient memory, or that means the buffer is full of the router, in that case also the congestion will occur. And if the router processor is slower than the processor at the sending end side node, say the sending end side node speed is more than the speed of the router, then since its speed is more, it will send more packets. But since the router is running slower, so it is not able to deliver that packets, then again the congestion will occur in a network. And of course we know higher the bandwidth, higher will be the capacity of the network, or higher will be the data rate. If the bandwidth is lower, then also the congestion will occur in a network. So these are the situations where when we said the network is being congested. Now, what is congestion control? By which means, or by the rules by which, or by using some protocols, how we get rid of this situation of congestion, that is known as congestion control. And it can be done in several ways. Before that, we come to the we see the difference between congestion control and flow control. Now flow control, we have seen when slow processor will receive a data from a fast sender. Now if the processor at the receiving end side is running slow, whereas the sending end side is running fast, then the it is not possible for the receiving end side processor to accept that data at the rate at which it is being sent by the sender. Then there will be a difference between due to the difference in speed, this flow see this situation has been occurred, and due to which how could we control that situation. What we have studied in flow control, this is being done in the form of an acknowledgement, and this acknowledgement also make the situation in such that both the sending end and the receiving end, though the receiving end side processor running slow, it can able to accept the packet. And also this acknowledgement signal also acknowledges the data packet sent by the sender without any error. We have seen this in case when we have studied flow control, isn't it? Now we are going to find out the difference between congestion control and flow control. Now here is an example. Say we have a fiber optic network having a capacity of 100, that this network has a capacity of carrying 100 gigabit per second. And if a computer is trying to transfer a file to a personal computer, that means the computer processor at the sending end side will able to send the data rate at 100 gigabit per second, and the network also having that capability of carrying the data rate or data in 1000 gigabit per second. But in the receiving end side, the receiving end side processor has a capability of accepting the data at 1 gigabit per second. Now, when in this situation, what we can say, there will be no congestion in a network, but there will be, we need a flow control. And in the second example, suppose we have a network having a capacity 1 megabit per second. That means the network has a capacity to carry 100 megabit per second. Now, in this network, we have connected 1,000 computers, and half of the computer is sending a data rate at 100 kbps per second to the computers which are at the receiving end side. That means at the sending end side we have 500 number of sending end computers or processor, and the receiving end side we have again 500 number of processors or computers, and both of them has both the sending end side processors and the receiving end side processors have a capability to send 100 kbps data, and the receiving end side computers has a capability to accept the data at 100 kbps. Now, under this situation, there will be no flow control because both ends processor are running at same speed, but the network is overflowed with a packet because the network capacity is only 1 Mbps. So for this example here, when this situation arises, there will be no flow control, but the network is being congested. Clear the difference between flow and congestion?
Yes, ma'am.
Yes, ma'am.
Now, how could we do congestion control? Now, it is first router centric because we have seen the situation just now. When we are going to, because the packets are being delivered through the networks, there are so many routers connected in the network, and the data will pass to send the information from sending to receiving end. Data will pass through the number of routers connected through a network. Now, in that case, to take care of congestion, to get rid of congestion, so router is responsible for that, because through routers the packets are being passed on from one node to another so that the packet will reach its destination. So the router has the responsibility which packets to forward, which packets to drop, and when the congestion is being occurred, it is the responsibility of the router to tell this situation to the sender, to the two hosts, that means sending end at the and also the receiving end side. And this can be done with the help of queuing algorithm. We are not going to study this algorithm um, here. This router then apply this algorithm to take and this algorithm is used to make a helps a router to make a decision which packets forward, which packets to drop, and how the buffer of the, because I have told you the router has a capability of storing the data in its buffer, and how it will control its buffer, that is solely depends upon the router, and router perform this with the help of queuing algorithm. Now, host centric. Host means the sending end and the receiving end. The end host will make a decision how it will take care of congestion, and this can be taken by observing the network congestion, network condition, sorry. And we will study this TCP congestion control mechanism, because then I have told you the TCP layer of TCP IP protocol architecture has taken care of both flow control and error control, congestion control also. So we are going to study how the transport layer can taken care of congestion in case when the congestion is being occurred in a network. That is why it is known as host centric. Now, second one is reservation based. Here the host attempt to reserve network capacity when the flow is established, and this reservation can be depends upon the receiving end side node or the sending end side node. Now, feedback based, here the feedback is being given to the two hosts when the congestion is being occurred in a network. First one is known as explicit feedback, and the second one is known as implicit feedback. In explicit feedback, when the situation is being occurred, when the network is being congested, then either the where the congestion is being occurred, it will send a signal or a node, because we are going to pass the data packets through different nodes in a network, what we call router. Then router will, if a router finds that there is a congestion in a network, so then the router will send a signal to both sender and receiver that the congestion has been occurred in a network. And here we will see later on, the two signals is being used. One is known as forward uh, back implicit congestion control, and another BECN, and another is reverse B backward um, congestion control signal. Now, forward congestion control signal means then in front of a router, say we have a sender and a receiver, and at the midpoint the packets will pass through a single router. Now, if the router finds that the congestion is being occurred in a network, so it will send FECN signal to the receiver, and BECN backward explicit congestion control signal to the sender. So since the in forward in front of router we have a receiver, and at the back of the mm, mm, router we have a sender. So the same signal sent by the router to the receiver is known as FECN, which is forward explicit congestion control, and the signal sent by the router to the sender is known as backward explicit congestion control. And this is explicit feedback. And in implicit feedback, what we do, the congestion, how the congestion is being indicated in a network. In the diagram or in the first figure, we have seen the when the packets is being sent or put through a network, but no packets are being delivered, uh, then we have assumed that the network lost the capability of sending or the packet through the receiver, and there will be a packet loss. Now, reaction to congestion. What happens when congestion will occur? And if there is no congestion, we are going to increase the data rate. And if there is a congestion, we will decrease the data rate. And how the data rate is being controlled with the help of congestion window size. Just like in flow control, we have seen we have to choose in sliding window protocol, flow control protocol, we have seen that we have to choose a window size, and how the window size will move. That is why we call the windows to be protocol to be a sliding window protocol to take care of flow. Similarly, here also the window size is being chosen, and upon the window size, the data rate will be depends upon. So when there is a congestion, we are going to slow down the data rate, and when there is no congestion, we are going to increase the data rate. And how the data rate is being controlled with the help of congestion window size. Clear?
Yes, yes, ma'am.
Now we are going to study. We are not going to study detail of congestion control, because there are several algorithms to take care of congestion, and we will here study only how the sending end and the receiving end side, receiving end host, and it's because both now the networks, the nodes or the computers are using TCP. All of the computers are using TCP IP protocol architecture. So the how the hosts TCP can take care of congestion when there is when congestion has been occurred in a network. And there are three algorithms, or three mechanisms, three protocols. One is known as AIMD, which is additive increase. AI stands for additive increase, and MD stands for multiplicative decrease. There is another mechanism, what we call to be a slow start, and there is another one which is congestion avoidance. These three different protocols are used to take care of congestion, um, of the when there is a congestion in a network by the TCP, by the host TCP. Now in AIMD, suppose the congestion window is being set here, this because this is the congestion window size. So when there is no congestion, the this is linear, it will increase, congestion window will increase linearly. And when suppose in this situation the congestion will occur, so the size of the window is being decreased. And again the we will then decrease the rate, and again the window is again increases as linearly. And when again congestion will occur, it will decrease. That means from here what we have seen, if say at when the congestion window size is 16 kilobytes per second, 16 kilobytes, and at this instant the congestion will occur, then it is, since the decrease rate will be multiplicative decrease, so it will be divided by 2, and it will be 8 kilobytes per second. And since the increase is additive, say here, then 8 will be the congestion window size, and it will increase by 1, say 8, 9, 10, 11, 12, and so on. The increase will be like this, additive increase. That means here when the congestion will occur, if the an acknowledgement is received, then there is no congestion. Congestion, and when there is a congestion, so it will be CWND by half. And when the congestion is reduced, then for each acknowledgement received, because congestion control and the flow control, it will both TCP is taken care of both the situation. So it will when there is no congestion, and the acknowledgement is received by the sending end side from the receiver, it means this acknowledgement means if it the sending end side receives acknowledgement, then there will be no congestion in a network, and also this acknowledgement tells us that the data packet has been sent correctly. We also taken care of error control also. So error control, congestion control, flow control, all of the situations have been taken care of by the transport layer of TCP IP protocol architecture. So in that case, the TCP increases its window size by 1. If it is 8, it will be 9, then 10, then 11, then 12, and so on. The increase is additive. That is why additive increase and multiplicative decrease. Say here, first it will CWND is 1, and we are receiving acknowledgement. Then we are going to increase the congestion window by 1. It is 2, we are receiving, and then 3, and then 4, and so on. So this is, but when the congestion will occur, the decrease will be multiplicative. Now in slow start, also the congestion window will increase, will start from 1. And so at the sending end side, CWND is equals to 1, and then we are receiving acknowledgement. Then we are going to increase the congestion window, and we are receiving acknowledgement. And here the increase is in slow start mechanism. It is exponential in nature. So at the start of the, or at the beginning, that is why we call it slow start. At the beginning, the congestion window always set to 1, and then we are going to increase the congestion window, and ultimately the increase is exponential in nature in case of slow start mechanism. Clear what we mean by slow start?
Yes, ma'am.
Yes.
Now, this slow start cannot continue indefinitely, because if the window size is growing so fast, then at a time there must be a congestion occurred in a network. So before we have to select a threshold level, which we known, or which we called slow start threshold, which is that is indicated as SS thresh. SS stands for slow start, and thresh for threshold. That, so it is slow start threshold. So up to slow start threshold, the increase in window will be exponential, and when it crosses when window size crosses this slow start threshold level, window will increase linearly. So that there will be no congestion in a network. Now, congestion avoidance, and in slow start algorithm, the congestion avoidance is being, and this has been shown here, how we congestion avoidance by additive increase. So here what we have seen, this is as a whole slow start mechanism is being showing slow start together with the congestion avoidance. Say CWND1 and then 2, then 4, and then 8, it will increase exponentially, and the slow start threshold previously, we are both the host will set the threshold level at 8, say here this is SS thresh. So when the congestion window, for an example, if it reaches 8, then it will grow linearly, 8, 9, 10, 11, 12, and so on. Now, even if in this situation also, if the congestion may occur in a network. Now, how to detect that situation? Now, this slow start is being taken care of both the congestion avoidance situation, but though we are in a slow start congestion avoidance phase, the congestion may occur in a network. And for this, we have for two situations, we can assume that the congestion has been occurred in a network. And these two situations, first one will be the timeout, and the second one will be the 3 duplicate acknowledgement received. Now, first situation is timeout or no acknowledgement is received. This is a sign of a strong congestion because we are not getting an acknowledgement from the receiving end side. And then the 3 duplicate acknowledgement received. That means here we are getting an acknowledgement, but the acknowledgements are duplicates. That means if we are receiving same acknowledgement thrice, then this situation will occur. But since we are receiving acknowledgement from the network, that is why we call this situation to be a light congestion occurred in a network, or the sign of a weak congestion in a network, because we are receiving acknowledgement but duplicate acknowledgement. Now, first, how we are going to handle this situation, this has been shown here. Now, here we are, every mechanism is start with a slow start mechanism. So the congestion window is set to 1, and here this will be the SS thresh. So what we have seen here, here the window rise is exponential in nature, and when it crosses threshold, the window in the increase will be additive. So here this curve will be linear, and here the timeout is being occurred. That means no acknowledgement at this instant of time. We are not going to receive any acknowledgement from the receiving end side, and this situation is known as timeout. Then what happens when this situation arises in a network? TCP knows that the network is heavily congested, and then what it will do, take care of congestion control. It will start drops the window congestion window to 1 again here, and then it will increase exponentially, and when it crosses threshold, it will again increase linearly. Clear the timeout situation?
Yes.
Now 3 duplicate packets receives duplicate SEKs. The number is usually 3. So to take care of this situation, we use two algorithms, or one is fast retransmit and another is fast recovery. Say this is CWND1. Always we are in a slow start phase. So CWND1, and we are receiving the acknowledgement. Then we are increasing, the window is increasing exponentially. Now here, when the CWND4, we are going to CWND4 means we are going to send 4 data packets at a time, and and due to congestion, the packet 4 is being lost, and but the other 3 packets is being received. Now, so therefore here for these 2 packets we are getting an acknowledgement SEK2 and SEK3. Now 3 duplicates, since the segment 4 is being lost, we are receiving 3 duplicate SEKs. Now when the sender will receive 3 duplicate 3 times the same SEK, then it will the sender will know that the segment 4 has been lost, and it will send that packet first retransmit the segment 4. Now why 3 SEK3, though it is duplicate, but it will acknowledge segment 5, segment 6, segment 7, but the acknowledgement number or the sequence number will be 3. Clear? This
Yes,
is the fast retransmit of the packet which has been lost in a network due to congestion. And next is fast recovery. Now here what we have seen in this figure, we always start with a slow start phase. The CWND is, look at this figure carefully, CWND is set to 1, and the slow start threshold which has been set prior to transmit the packet, it is at 6. Sorry, no, it is at 8. Here is the, because here is this the different situation. No, it is being set at 8. This is a slow start threshold, and after that, because here to take care of congestion or slow start and congestion avoidance, we have seen the window grows linearly. Now at this instant of time, or when the window size is being 12, then we are getting 3 duplicate SEKs. Then in this situation, what will happen in first recovery, the window is set to CWND is being set to CWND by 2 plus 3, which is being shown here. The go to the diagram, say here at when the CWND size is being 2, the 3 duplicate SEK is being occurred, and then the CWND drops to 9. That means if it is 12, CWND by 2 plus 3, because since we are receiving 3 acknowledgement and that is 3 duplicate SEK, so the CWND will be set to new CWND is being set to CWND by 2, which is 12 by 2 6 plus 3 equals to 9, and then the window grows linearly until we are going to receive the new acknowledgement of the delivery of a packet, and then the window size is being halved, which is 6, and the window grows linearly. So this is first recovery. You understood this situation?
Yes, ma'am.
So these are the TCP congestion control mechanisms. And besides, we have another 2 variants of TCP, which is known as TCP Tahoe and TCP Reno. TCP Tahoe, this implements slow start, congestion avoidance, and fast retransmit. And TCP Reno, it will implement slow start, congestion avoidance, fast retransmit, and fast recovery. Now let's see here both TCP Tahoe and Reno can be explained by if we consider this figure. Now here the green one will be the TCP Reno and the red one will be the TCP Tahoe. And here we have taken 2 congestion, the 2 situation of congestion, both light congestion and heavy congestion. Heavy congestion is denoted by timeout, and light congestion or weak congestion is denoted by 3 duplicate SEK. So here always we are in a slow start. So congestion CWND, we start with congestion window, start with CWND equals to 1, and the window grows exponentially, because 1, then 2, then 4, then 8, and after SS thresh, to get rid of congestion, slow start and congestion avoidance, because both TCP Tahoe, it consists of slow start and congestion avoidance, and then fast retransmit. So here 3 duplicate SEKs occur, and then the congestion window is being set to 1 in TCP Tahoe mechanism, is set to 1, and again it is slow start, and then now here since it is 12, so the congestion window is being halved. The situation will be different for TCP Tahoe and Reno for 3 duplicate SEKs, and that is why we have 2 variants here, Tahoe and Reno. So CWND1, and now it will be in a slow start phase, and it is up to congestion window 6, because when 3 duplicate SEK occurs in TCP Tahoe, then the CWND will be equals to half, because here for red one, which is Tahoe, it is 12. So the SS thresh will be 6, CWND by 2, which is 6, and actual CWND will be equals to 1, and we have a here slow start, then congestion avoidance, and here timeout occurs, then it will since here it timeout occurs, so CWND will be equals to 1, and here the threshold will be select as a 4, and the window grows linearly. So this will be TCP Tahoe, and in TCP Reno, when 3 duplicate ACK occurs, it is more or less through to the 3 when 3 duplicate ACKs occurs in first recovery, because Reno uses first recovery. First recovery algorithms. So when the 3 duplicate ACKs occurs, the CWND will be CWND by 2 plus 3. Now here it will be 6 plus 3, which is 9, and the window grows linearly, and then the timeout is being occurred, and it is 16. Now when timeout is occurred, CWND will be equals to 1, and we are in a slow start phase, and up to this the window set will be CWND by 4, which is 16 by 2, which is again 8, and the window grows linearly in case of TCP Reno. So these are the two variants of TCP again, besides slow start, congestion, additive increase, multiplicative decrease, and congestion avoidance. And that is known as TCP Reno and Tahoe, and how we are going to take care of TCP, take care of uh, to control the situation of congestion for both the two variants. The take care of congestion avoidance mechanism will be different, and it is shown from these two graphs. So clear? Hello?
Yes, ma'am. Yes,
So
ma'am.
this is all about the congestion control. Now we will move on to LAN. Okay, I am not delivering. Let me present the topic first, then I will start. So we are going to study now local area network. Now local area network, I have told you before, it is the covered area by the network will be a small geographic area. It is say a single floor in a building, all the floors in a building, all the departments in a campus. So this will be the size of the local area network. And in local area network, so this will be the configuration of local area network. And in local area network, we have a one computer which is known as a server, and the other computers which are connected in the network is known as workstation or node. Now what is the function of a server? The server will store the software to control the local area network, as well as it store the software, how could it will share the information through the workstations connected in a network, and that computer is known as server, and other are known as workstations or node. And each workstation or nodes is provided with NIC, which is nothing but a network interface card, and it will contain, it is a hardware device by which we can connect each workstation through the each workstation or nodes to the network, which we defined as a local area network. We can, how we can connect printer with the network through network interface card, how we connect nodes to the network through network interface card, and of course we need a cable. So this will be the overall configuration of local area network. Here one computer is designated as a server, other computers are designated as a workstation, and each workstation is provided with a network interface card. And network, since it is a hardware device, now I have told you when we are studying TCP/IP protocol, in first chapter, which is Introduction to Computer, the protocol architectural layer, the lower layer or the bottom layer will be on hardware, bottom layer, and the data link layer may be hardware part, and all other higher layers are implemented in software. So network interface card will fall in either in the physical layer or a data link layer, or we call this to be a data link layer device or a physical layer device. Now, how we are going to connect the server and workstation in a network, that topology can be, in case of local area network, is divided into 4 categories. One is bus, another is tree, third one is ring, and fourth one is star. Now here, this is the bus topology. Here this will be this is the main cable, and the cable at the end we have terminators. Now you know the why we have terminators at the end of the cable, and these terminators are being grounded. Do you have any idea? পাওয়ার সিস্টেমে টার্মিনেটরটা কেন থাকে বলো তো? পাওয়ার সিস্টেমে why?
ম্যাম এখানে কি সিগন্যাল রিফ্লেক্ট না হওয়ার জন্য থাকে?
Yes, perfectly right. So we have a terminators at both end of the main cable, and each workstations and server is joined to the network with the help of network interface card and a cable. These are the cables, and this cable is bidirectional. That means signal is bidirectional. That means it will receive signal. Each workstation or server will receive information from the bus, as well as the server and the workstation will send information through the bus. So the signal is bidirectional. Now, one is, and out of the several computers connected in a network, one is known as server, because in a local area network configuration, we have seen that one computer is designated as a servers and others are the workstations. Now, and the information transmission will be broadcast in nature. That means when the any information is sent by the workstation, it is first coming on to the main cable, or which is shown like this, uh, or a straight line or a single cable. Then mm, the information will be, say this workstation will send an information. Now this information sent will be broadcast in nature. Why broadcast? Because all other stations connected in the network will receive the same information, and the signal flow is both the ends. That means when it send an information to the bus, we call this, since it is a bus topology, we call it to be a bus. The signal flow will be along this direction, as well as from this workstation will be along to the right hand side as well as left hand side. Now, since the information transmission is broadcast in nature, that means all other workstation will receive the same information. So there is a technique to care that only a particular workstation is being received the information, and for that when any workstation will send an information to other workstation, it will mention the address of that particular workstation. That means here in this figure, what we have seen, say C wants to send an information for A, and the address of A is mentioned in the data packet. But when it passes through B, since it is broadcast in nature, so it will come to B. But since B then tests the information or the data packet in such a way that it will neglect that information by seeing the address mentioned on the data packet. Now here the address of A is being mentioned here. So when the data packet comes to B, B will reject it by seeing the address part of the data frame, and then it will go, and when A, it comes to A, since the address of A is matched with the address of the data packet, A will accept the information. So the advantages, it is easy to connect a computer or peripheral to a bus and requires less cable length than start topology. When we will see the start topology, then we will understood why the less cable length is required in bus. And disadvantages is that when the bus fails, then the whole network is being shut down, and terminators are required at both ends of the backbone cable, and difficult to identify the problem if the entire network shutdowns. Due to why this problem, it is very difficult to distinguish whether the fault is due to the main cable, or due to the fault in the cable of the workstation, which is used to connect the workstation with the main cable. And I have told you already how could we take care of the, so that the others, the station whose address is mentioned on the data packet, that station can take in the information. Other stations will discard it by putting an address of that particular station. Now we can extend this bus with the help of repeaters. Here a repeater will send a signal. Repeater will send a signal both the directions. That means, say, this repeater, since it sends both signals in both directions, that means it is to in this segment as well as this segment. Now why this is being so? Because if the station A on these segments wants to send information to the station which is on another segment, then the repeater will accept that information from this segment and send the information to the other segment. Similarly, if this segment this station wants to send an information to this station, repeater will again accept the information from this segment and send the information to other segment. So in this way, we are going to increase the size of the local area network in bus topology. But since the repeater will not isolate segment 1 from segment 2, and since by connecting or by using these two repeaters, it means that all of the station are on the same LAN or same bus LAN. That is why there, when both the stations, when say one station say in segment 1 and one station in other station in segment 2 will want to send an information at the same instant of time, there will be a collision amongst the information sending by the two stations on different segments. So in case of a bus, the how to send an information between the workstations and the file server, we have to use Csma Cd protocol, which I am coming later after this configuration part. Now this is how we increase the size of the LAN with the help of repeater. Now we have in dual bus, we have two separate bus, and these two one is sending end bus, another is receiving end bus, or which we call transmit bus and the receive bus. Both of these two buses from the figure is end with a terminator, and here and one side of the transmit and receive bus is being joined here, so that, and say these are the station, it will when A wants to send an information to C, it first transmit this send the information to the transmit bus, then the signal goes through this and it will be received by this C, the station C. And of course, I have told you how the station C will accept the data packet, where B will discard, because A will mention the address of C on the information packet. And also this dual bus using FDM, that means it uses two carrier frequency, one for transmission and another for reception. And we have a frequency translator at the other end. If F1 be the transmitting frequency, F2 will be the receiving frequency, or F1 is being translated to F2 with the help of frequency translator. And we have seen how the PLL, as for example, PLL device can be used to translate one frequency to other frequency in our electrical instrumentation course. And this is a dual bus, and dual bus using frequency division multiplexing technique, so that we can able to transmit more than one information at a time. Now this is the tree. This is again a general form of a bus, and this will be the main tree trunk or main backbone of the tree topology. And these are the branches, and the branches are terminated with the help of a terminator, which hasn't been shown here. And we are connecting the workstation like this is, and when there will be a fault in the main trunk, then the whole network is shut down. Now we come to the star topology. So here now it looks like a star, because here in star we have a same common point for all the workstation, which we call to be a concentrator or a hub. And each workstation, each server is being joined to the hub separately. Say, to join the file server to the concentrator or a hub, we need two cables, one for transmission and another for reception. Similarly, for the workstation and printers also, we need two cables, um, one for transmission and another for reception for each workstation, printer, and a server. Now here the when we can, since if we want, we can connect more workstation easily, because if we want to connect more workstation in this configuration, and we can connect it with the help of this. And also here also the transmission will be broadcast in nature, information transmission. Say, when this node is wants to send an information to this workstation, it will first send the information to the hub, and then all of the station, because all of the stations are connected to the same hub, so all of the station will receive the information. And in that case, this is only known as a hub, or we call it a passive hub. But if the uh, signal is being amplified, and then it is being sent through the that to the workstation, then it is known as active hub. And if the it is a intelligent hub, then the situation will not be broadcast in nature. Then when this workstation will send an information, say for a particular station, send an information, then the when the hub is receiving that information, and if the strength of the information is low, or its amplitude, because it is nothing but an electrical signal, so if the signal amplitude will be low, it will amplify the signal, just behave as an active hub. But why we call it intelligent? Because the hub then transmit that information to the particular workstation whose address is being mentioned on the data packet sent by this workstation. So is it clear what we mean by passive hub, active hub, and intelligent hub? Yes, ma'am. Tell me, what is the difference between passive hub, active hub, and intelligent hub? কি হলো? এই তো ইয়েস ম্যাম বলে ফেললে। In active hub, no, that is not true. Here in terms of, I am not saying in terms of power.
Ma'am, passive hub does not help in rectifying the signal, and they just pass it to the network.
Yes, and what is active hub?
Um, Ma'am, like active hub
It will
stores the data for
amplify
some
the,
time.
no,
Yes,
no,
ma'am.
it will amplify the signal. Passive
Okay,
hub will
ma'am.
not amplify the signal. It will send the data through the workstation only. But active hub, because when we are going to send the signal will be impaired by transmission impairments. So in order to get rid of that, if it is active hub, it will amplify the signal as well as modify the signal and then send it to the that workstation. And in case of an intelligent hub, not in both active and passive hub, the difference is in signal amplifying purpose. That means active passive hub, there will be no amplification of the signal, and the signal is being received by all other workstation because it is broadcast in nature, and by seeing the address, that station will accept the data. In case of an active hub, it will amplify or rectify the signal, and that amplified or rectified signal is available, or in terms of an information, it is electrical signal is nothing but, and here it is an information sent by one of the workstation connected in a hub in star topology. All other station will receive that amplified signal. But if it is an intelligent hub, the address, the function of the intelligent hub will such that it will amplify the signal and it will send the information to that particular workstation, because any data transfer is being done through ports. So the intelligent hub has both input ports and output ports. It contains, so it will receive the data from any workstation through input ports, and then it will activate its output ports in such a way that the information is meant for that which particular workstation, that output port will be activated and the data goes directly through that workstation. So it is an intelligent hub. Clear? হ্যালো,
Yes, ma'am.
সত্যি ক্লিয়ার হলো তো? কেন ইন্টেলিজেন্ট হাব বলছি? because say it is connected to one port, it is connected to another port, it is also another port. So, and say this workstation is send the information for to this workstation for this particular station, and the port at which this network is being this workstation is being connected, or this node is being connected, the data will go through that ports only and not to the others. It has the hub has a capability, by seeing the address it will send the data through that line, so that it will goes directly to this workstation. Whereas in case of both active and passive, the inactive the amplified signal, and in passive without amplification of the signal, that information is received by all of the workstation connected in this hub. Kintu intelligent hub hole only that particular station will receive the information, and none of the other station will receive the information.
Yes, ma'am. Understood, ma'am.
That is why we call it intelligent hub. Now then we have a ring. Here it is in the form of a ring, because all the stations is in a closed loop, and we have a repeater to connect each station to the ring. And we have here, though we have shown single bidirectional cable, but here we are using two separate cables, one for transmission and another for receptions, just like in star. Here we have seen we have two cables, and here the signal flow in one direction only. That is if the station, this station will send an information, the signal will goes through all the stations and then ends up here. Signal flow is in one direction, whereas in bus we have seen the signal flow in both ways. And when the repeater fails, the ring network, ring topology will fail. Here, if any fault occur in a workstation itself, then the other workstations will work. There will be no disruption in a star network. But if the concentrator or hub, this hub fails, then the whole network is shut down in case of star. Now here the information, since the signal flow in one direction only, so if the A is sent and station C is sent an information and the signal flow either in clockwise or in anti-clockwise direction, but in unidirectional, whether it is anti-clockwise or clockwise. So here, and it is being explained with the help of this figure. Say station C is sent an information for an A, so it will mention the address of A on its data packet. So, and we have assumed here counterclockwise direction of rotation of the signal, so it will comes to B. So this B, and B will check and finds that it is not meant for it, because the address of B is not matches with the address here. Then it will again so it will reject the data packet, it will not accept it. So the signal passes and then comes to A. A will again check the signal, and since it is meant for A will absorb the signal, and again the data packet goes back and end up here. So here will be the here, from here the signal starts and here also the signal ends. And if the repeater fails, then there will be a shutdown in a network. And repeater installation is cumbersome and in ring break down the entire network also. Now LAN transmission medium, it used in wireless LAN. The transmission medium will be falls under unguided. And here it is a guided transmission medium, either copper, twisted pair cable, coaxial cable, or optical fiber. And radio is for wireless LAN. And we have two types of LAN, baseband LAN and broadband LAN. In baseband LAN, the signal is being transmitted without any modulation, and in broadband LAN, the signal is being transmitted after modulation. And also the distance cover will be more in case of broadband LAN than baseband LAN. And here in baseband LAN, we are using Manchester or differential Manchester encoding technique. And in broadband LAN, it is transmission and reception will be at two different frequencies. The transmittant frequency is 1 and receive frequency is F2, just like in dual bus. Now Lan Protocol Architecture, it has a 5-layer architecture. Bottom layer is physical layer, which is implemented in hardware. MAC layer and the LLC. Here the data link layer in case of LAN, we divided into two. One is medium access control layer and another is logical link control layer. Then we have an internet layer, transport layer, and application layer, just like in TCP/IP architecture for computers which are not connected in LAN. If the computer is connected in LAN, the data link layer is divided into two. One is MAC and another is LLC. Now the function of the physical layer, and this architecture was adopted or developed by IEEE 802 committee, and so this is known as IEEE 802 reference model. The TCP/IP protocol architecture is known as IEEE 802 reference model. And here the data packets, application layer data is known as application data, and TCP layer data is known as TCP segment. Then this TCP segment is passed through the IP layer, and IP layer data is known as IP datagram. Then it passes through the LLC layer. It is known as LLC protocol data unit. And then we have a MAC layer. Here this is a MAC layer, and this is known as medium access MAC layer, or we call it to be a MAC frame. And MAC frame has both header and trailer to show the start and end of the frame. And this MAC frame is circulated over the wired LAN. But in wireless LAN, the frame size will be different. So this is the medium access control frame that has been transmitted over the transmission medium, is known as MAC frame in case of a local area network. Now the physical layer, it is encoding and decoding of signals. Now when the signal data, because 1 and 0 comes to the physical layer, we cannot able to send 1 and 0 through the transmission medium. So we have to at the sending end side, we have to encode the signal. Similarly, the receiving end side computer will have to decode that electrical signal into digital data form. So it is the function of the physical layer will be both encoding and decoding of signals. Preamble generation, this is for synchronization between the transmitter and a receiver, and it is responsible for bit transmission and reception, and it also specifies the transmission medium. Now the MAC layer, it governs the access to the LAN transmission medium, and it uses now how the workstation will access the medium to send the information, um, that is being decided by the medium access layer in case of Lan Protocol Architecture, or which we call IEEE 802 reference model. And here we are using two different protocols. Not two, we will see there are several protocols. One of the protocol is known as Csma Cd Protocol, which is carrier sense multiple access collision detection protocol. Then there will be a token ring protocol. Then there will be a round robin protocol, and there is a token bus protocol. And these protocols are used for different topology of LAN. Say bus tree and star uses Csma Cd protocol, whereas ring uses token ring protocol. And FDDI LAN also uses a token ring protocol, but that protocol is slightly different from the actual token ring protocol used by ring topology. And that topology, we call it FDDI LAN, which is fiber distributed network interface. Fiber distributed data interface network, FDDI local area network, because that network is made up only with optical fiber. And in that case, the protocol is known as dual ring protocol. And besides we have a round robin protocol. I am come to these protocols one by one. Now, so therefore one of the function, pardon? I am coming to that. First, we are going to start with Csma Cd protocol, which is now Csma stands for carrier sense multiple access, and CD stands for collision detection. Now, so why collision has been occurred in a LAN, and how since the function of the medium access layer is to tell workstation how it will send an information through the medium to other workstations. So that is why it will govern the access to the LAN's transmission medium. And for this, it uses the protocol, which is known as Csma Cd, token ring, round robin, token bus, so much of protocols. Now come to the Csma Cd protocol. Now here, the first step in the protocol is that the rules for Csma Cd, if the medium is ideal, then then each station will transmit the data, and if the medium is busy, the station will wait and when the medium is free, then the station will transmit the data. And how the collision is being occurred, and why the collision. Now suppose here at the time t0, the A is going to, A finds that the medium is idle, then it transmits the signal. And we have seen in case of a bus, because this is a bus LAN we are showing in this diagram, and in bus LAN I have told you the signal flows in both the directions, that means towards the right hand side and to the left hand side. So since the signal, that is why the signal will flow along this direction and as well as in this direction. Now when B will B will sense the medium, and it found the medium is busy because during time t1 the signal propagates and it comes nearer to the B. So when it senses the medium, it finds that the medium is busy, so it will not transmit. But since C, it is far from station A and the signal not yet proceeds nearer to C, at the instant of time t1, C finds the medium is idle and then it begins to transmit. Now since the transmission is in both ways, so the signal will go through this as well as along this side. Now as the signal proceeds at instant of time t2, these two signals will collide each other. Now how we will know the collision? Because there will be a swinging of the voltage signals. By seeing this unbalanced swinging of the voltage signals, that means its amplitudes uh, are not remain the same as that of the amplitude of the signal which is being at these two instant of time. So then the collision will occur. And how the station will come to know that collision has been occurred? Now since the collision is being occurred very near to C, so C will see the situation, it will not going to transmit, but still A will began to transmit, or will continue its transmission, because the collision has been occurred far from A. And B will, since collision occurs near to C and B, so B and C will cease transmission at T2, but A will not cease its transmission, because it is not possible for A to know this situation, and it will transmit. And when this swinging of the pulse or the collision signal is reaches, that is why the collision signal is shown by this type of symbol, whereas the actual transmission by A is, or also the C, which is the actual information signal, and this is the collision signal. Actual information signal is shown by this symbol here. So now at the instant of at time t3, when the collision signal reaches A, then A will cease the transmission. Now when this situation will occur, when the collision will occur, and why this is happened? Because every nodes connected in a bus topology has an access to the medium, so that it can able to send its information to other stations, and the signal flow is bidirectional. That means if the C is sent an information for D, and if it is unidirectional, then it will flows through D, goes to D only, not along this direction. But since it is bidirectional in nature, so it will flows in both the direction. Now, when this situation will occur, and the collision has been detected, then each station will wait for a random amount of time, and this random amount of time is being calculated with the help of binary exponential back-off algorithm. We are not going to study this algorithm, but this algorithm will find out a time how long each station will cease transmission, and then when that time elapsed, the network nodes can again transmit their information. If a single collision will occur, then each station will wait for a single random amount of time. If more than one collision, say collision, to again the collision will occur, say there are two collisions, then the station will wait for twice the random amount of time. If third collision will occur, then the each nodes on a LAN will wait for three times that random amount of time, and when that time elapsed, the network will again transmit its information. So that is why, and carrier sends multiple access because multiple nodes have an access to the medium, and each node can able to send information at any at any instant of time. Clear what we mean by Csma Cd? It is not an unidirectional, it is a bidirectional thing. No, when these are the different instant of time. If they were say at t1 instant of time, B, A and D can able to send the information, and just like C, since the signal sent by A and C will be far beyond, and B is nearer to A. So when C and D can able to transmit at same instant of time, because it will find the medium will be idle, but still the at some time, say the collision occurred at t2 instant of time, there might be collision occurred at t3 instant of time, only the time will be different, but the collision will occur. Clear my point? Because the signal flow is bidirectional. If it is token ring, since ring protocol, since we have seen the signal or information transmission is one direction only, there no collision will occur. That is why this protocol is named as Csma Cd collision detection. Csma is because the more than one station have an access to the medium. That is why multiple access, multiple nodes have an access to the medium. And if it is a broadband LAN, it will sense the presence of the signal by sensing the carrier signal. That is why it is known as carrier sense multiple access and collision detection. Whereas in case of wireless LAN, it is very difficult to find out the collision. So there also a collision. So but their protocol is built in such a way, it is Csma Ca, that means carrier sense multiple access collision avoidance. And in that case, how we avoid collision in case of wireless LAN, we will study that later on when we are going to study wireless LAN. Okay, but here in case of wired LAN, this protocol is known as for bus and start, it is Csma Cd. Clear? Hello. Now this is a token ring protocol. Here, prior to how the collision is being avoided, and never collision will occur in a ring network. This is not only due to the signal circulating in one direction only. We have prior to transmission of actual information, there will be a token circulate within the network, and the node which is able to get that token, that has a permission to send the information. Let's see what is that. So this figure describes token ring protocol. So here in this ring, we have 4 stations is being connected, and prior to transmission, sending an information between the nodes connected in token ring or in a ring LAN, a token will be circulated, and this token will be a small data frame. The size of the data frame will be less than that of the size of the data frame that has been circulated as an information, which we call MAC frame. In case of local area network, the size will be less. Or so the token will circulate within the ring, and here also, since the flow is in one direction only, so here I have assumed it is counterclockwise in nature. So now when it circulates within the ring, so A is uh, got hold of this token. Now A will able to transmit, and all other station, though they have a capability to transmit, but they remain idle because B, C and D couldn't get the token. Now when the token is being taken by A, then it will transmit its information, which is MAC frame, and it is being circulated within the ring, and the address being mentioned, I have told you in a LAN, since the address of a particular station has to be mentioned, so it is meant for C. Here C, address of C is being append in the data frame. Now when the signal comes to D, D says it is, D finds that it is meant for C, so it will discard the signal, and when it is comes to C, C will accept it, and then again here D wouldn't accept, and it the signal goes away, and here then it comes to C, C will accept the data frame, as well as the signal ends at the start end or the starting station. The signal will end at the starting station. So since A will be the starting station, so the signal will passes through B, and B, it is not meant for A, so B will reject it, and it will passes by, and then the signal ends up in the station A here. So the C will come to A again. Now next, when it will receive the data frame, the A will release its token. So, and then another station will take the token and transmit its information. So in this way, we are, since when the token is seized by any one of the station connected in a ring, no other station has a capability to transmit the information, and also the signal flows in one direction. So there will be no collision in ring. Okay.
Yes, ma'am.
Yeah, that is the disadvantage of token ring protocol. And how could we increase? Because if the network capacity to carry more data, but we can take only single, it will accept only a single data frame. Okay, please excuse me for 1 or 2 minutes. Now this can be improved by using two mechanism. One is by token ring priority, and another is by including token holding time. So the disadvantages of this protocol is flexible control. Disadvantages will be requirement for token maintenance. Loss of token prevents, and if the token is lost while the token is being circulated in a network, then no stations can able to send their information. A duplication of the token can also disrupt ring operation. And one station must be selected as a monitor to ensure exactly one token is on the ring, to ensure that a free token is inserted. Now, how could we improve this token ring protocol? I have told you which is the token ring priority, including token holding time, and another is early token release. Now, what is token ring priority? Now the station which has a priority, that will seize the token first, just like in 8085 CPU. For interruption, there we have 5 interrupts. One is RST RST1, RST2, 3, and another is what is the 5 interrupts? Do you remember? And they and these there are different yes, RST 6.5, RST 7.5. Yeah, trap has the highest priority, isn't it? Then we have RST 7.5, then RST 6.5. RST 6.5 has lowest priority and trap has highest priority interrupt. 4 or 5 interrupts, I have forgotten really, but trap has the highest priority. Here also, we are going to mention priority on the token and the station which has a highest priority, which have most important information to be sent, that station will seize the token. By using priority, that can be taken into account. then early token release. And now early token release means here the token will be released by the node when the signal will come to the back again to A, which is sending the information, or which is sending end host, sending end host, yes. And early token release means as soon as the data packet is being sent, the token is being released by the station. Then the other station can take care, seize the token and transmit the information. So by early token release, we can able to send more than one information at the same instant of, at the same time on a ring LAN. Yes, but I have told you the token is a very small data unit. So the size of the frame is less than that of the data frame. So the speed will be, of course, low for the token to circulate. Clear? But there will be more data frame. In case of token ring, there will be only one data frame circulating within the ring, so we cannot able to use the full capacity of the ring. But in case with early token release, we can increase the capacity of the network, because with the help of that, there will be more information on the, more than one information on the ring. And also by token holding time, how long the each station will hold the token, that has been mentioned on the token data frame. So in this way, we can improve the token ring protocol. Clear? By token priority, early token release and token holding time.
Yes, ma'am.
Okay, I am ending up here today. Thank you very much for listening. Okay.